In this video, we'll see how to simplify radical expressions. So we know the square root of 9 is equal to 3, but let's just try to understand this a little bit better. 9 is equal to 3 squared, or 3 times 3. And so when I take the square root of 3 squared, I just get the base as the answer. If I was to try to take the square root of 4 squared, which is 16, again, the base there, the 4, is the answer. If I was to take the cube root of 5 cubed, the base, 5, is the answer. And this is sort of a key understanding when we're simplifying radicals. So let's look at the square root of 18. That is not a perfect square, but I can simplify it. It's kind of similar to simplifying fractions where we're looking for factors to use. So first thing I'm going to do is I'm going to find the prime factors of 18. Remember, to find the prime factors, I am just going to break this up. I know 18, I can find it by doing 2 times 9. You could use 6 times 3. That would be fine too. 2 is prime, but 9 is not, so I want to break that down further to 3 times 3. These are the prime factors of 18. 2 times 3 times 3. And this is what I'm looking for. Since I'm trying to find the square root of 18, I'm looking for these perfect squares. So I'm going to rewrite this as the square root of 3 times 3 times the square root of 2. And we know that this is equal to the square root of 18, because 3 times 3 times 2 is 18. Well, I know the square root of 3 times 3 is just 3, and I'm going to multiply that times the square root of 2, and that's going to be equal to the square root of 18. Go ahead and pause this, check this on a calculator, and see that both of them are equal. They're both about 4.24. Let's see another example. 450. I want to simplify this radical. Well, 450, I know I could break this down into prime factors. I could do 10 times 45. 10 I could break down into 2, which is prime, and 5, which is prime. 45, I could break this down into 5, which is prime, and 9, that's composite. So 9 I'm going to break down to 3 and 3. And again, I am looking for these perfect squares here. So to simplify the square root of 450, I am going to rewrite that expression as the square root of 3 times 3 times the square root of 5 times 5 times the square root of 2. And again, I'm just choosing all those prime factors that I found. Well, I know the square root of 3 times 3 is just 3. The square root of 5 times 5 is just 5 times the square root of 2. 3 times 5 is 15. 15 square root 2. Now, if you really know your perfect squares, you may have noticed that 450 is made up of 225 times 2. And if you knew the square root of 225 is 15, then you could just simplify it as 15 times the square root of 2. So if you know those perfect squares, sometimes it's a little faster than finding the prime factors. But again, take a calculator, find the square root of 450, and then do 15 times the square root of 2. You will get the same number. And now let's look at this if it's a cube root. So if it's a cube root, I'm going to do the same thing. I'm going to find the prime factors of 162. I know that's 2 times 81. 2 is prime. 81 is 9 times 9. 9 is 3 times 3. 3 times 3. These are my prime factors. Now I'm looking for the cube root, not the square root, the cube root. So when I look for this, I want to get groups of 3 factors. So the cube root of 3 times 3 times 3 times the cube root, and what are my leftover factors? Well, I used 3 of these 3's, so it's going to be the cube root of 3 times 2. The cube root of 3 times 3 times 3, that's just 3 times the cube root of 6. And again, these two expressions are equal to each other. It's just the bottom one's the simplified one. All right, here are a couple for you to practice on your own. The square root of 32. I'm going to break 32 up into its prime factors. I know 32, I can find it by doing 4 times 8. 4 is 2 and 2. 8 is 2 times 2 times 2. I'm looking for those perfect squares. So here and here. So the square root of 2 times 2 times the square root of 2 times 2 times the square root of 2. Well, the square root of 2 times 2 is just 2. Square root of 2 times 2 is 2 times the square root of 2. 2 times 2 is 4. 4 times the square root of 2. That is equal to the square root of 32. You may have also seen, though, and again, this is where it helps to know those perfect squares. 32 is made up of 16 times 2. So you could just do the square root of 16, which is 4, times the square root of 2. All right, 252. This one I'm going to break up into its prime factors. 252. I know 252 is going to be 2 times 126. 126 divided by 2, that's going to be 2 times 63. 63 is 9 times 7. And 9 is 3 and 3. Again, I am looking for those perfect squares here. So I'm going to rewrite this as the square root of 2 times 2 times the square root of 3 times 3 times the square root of 7. Square root of 2 times 2 is just 2. Square root of 3 times 3 is just 3 times the square root of 7. Let me simplify that. 2 times 3 is 6. 6 times the square root of 7. And again, you can get a calculator and simplify that. And see that you get the same decimal. All right. Now, what does this mean? I want to simplify this radical, and this is 6 times the square root of 200. So again, I am going to find that square root of 200. I'm going to simplify it. And I'll start doing that by finding the prime factors. Did you notice that 200 is just 2 times 100? So if you want, you could rewrite this as 6 times the square root of 100 times the square root of 2. We know that the square root of 100 is just 10. So this will be 6 times 10 times the square root of 2. That's 60 square root of 2. And again, get a calculator. Find the square root of 200, multiply it by 6. Find the square root of 2, multiply it by 60. You will get the same number. Notice that I used that perfect square 100, but you could have broken this down further, and found all the prime factors. You would have ended up with the same answer. All right, here are a couple for you to practice on your own. 3 times the square root of 72. I want to simplify that radical. Well, 72, I'm going to break that down into 9 and 8. 9 I'll break down into 3 and 3. 8 we know is 2 times 2 times 2. I'm looking for those perfect squares here. I see 2 3s, I see 2 2s, and then that leftover 2. So 3 times the square root of 72 is just going to be 3 times the square root of 3 times 3 times the square root of 2 times 2 times the square root of 2. Got to make sure you're using all of those factors, right? And a quick check is just knowing that 3 times 3 is 9, 2 times 2 times 2 is 8, And you see we have 72 under the radical sign here. Well, this is going to simplify more to 3 times 3 times 2 times the square root of 2. 3 times 3 is 9. 9 times 2 is 18. 18 times the square root of 2. And last but not least, 2 times the square root of 175. Again, let's find those prime factors for 175. I know it's going to be 25 times 7. And 25 I could break up into 5 and 5. So to simplify this radical, it's going to be 2 times the square root of 5 times 5 times the square root of 7. This is going to be 2 times 5 times the square root of 7. 2 times 5 is 10. 10 times the square root of 7 is our final answer. And again, we're simplifying the radicals. You can check with a calculator, you'll get the same decimal. But lots of times it's just easier to work with these numbers if they're not these big, long decimals, but we see them as simplified radicals. Okay, I hope that helps. Good luck with the rest of your work.